Hello and welcome friends. In this particular module, we wish to discuss about the temperature and solar radiation effect in the context of air pollution. We'll discuss here factors that are affecting the atmospheric temperature as a meteorological parameter, the interaction and the distribution of the solar radiations, as well as the factors that are affecting the distribution of solar radiations. As you learn the content, you will be able to explain how air pollution is related with the temperature and solar radiations. What is atmospheric interaction with the solar radiation, as well as the change in the Earth's temperature according to the incoming solar radiations. As you know, the dynamics of the Earth's atmosphere is closely associated with the temperature and solar radiations. The temperature at a place is influenced according to the location of the place, as the amount of energy being received will be different at the various locations. Also, as we think of altitude, the temperature goes on decreasing. As we know, as we reach in the high altitudes, there will be decrease in the pressure, which has the direct influence on the temperature, as well as even we can consider the less presence of the carbon dioxide, as well as even the reduction in the water vapor, and hence as we go in the high altitudes there will be decrease in the temperatures. Also, we have discussed about the land breeze, sea breeze. During the night time, as we consider the heating of the land, as well as cooling of the water body will be taking place with different manner. Hence, during the night time there will be air current which will be moving from the cool land masses to the warmer water masses. Whereas during the daytime the situation will be just reverse, and there will be sea breeze or there will be water breeze. Hence, there will be the change in the temperature even in association with the water body. As we consider the occurrence of the warm as well as cold fronts, the places which come under the influence of the cold air masses will cause the movement of the warm masses at the further altitudes, and the region will experience the lower temperature. Even we can consider certain local aspects, say for example, if there is a less green cover, if there is a kind of heat island effect, if the topography is such that it is allowing the retention of the heat, so accordingly in the immediate vicinity of such regions, there will be difference in the temperatures. We know that the solar radiations provide heat, light, as well as energy necessary for the entire life that is existing on the earth. This is one of the facts that if the solar radiations were not there, the earth's surface would have been about 32 degrees centigrade colder than what is in the presence of the solar radiations. Also, the ozone generating photochemical reactions of the air pollutants like oxides of the nitrogen, methane, volatile organic compounds need high temperature as well as bright sunshine. If we consider the vegetation, during the high temperatures which induce the drought stress, it inhibits the stomatal uptake of the ozone. Also, a close relation is found between the temperature as well as the respiratory diseases, the susceptibility to the diseases and the deaths according to the various researchers. The solar radiations are associated with the ultraviolet radiations, which would alter the behavior and ultimately the survival of aquatic organisms. The solar radiations can be considered reaching towards this Earth's surface in different manner. Essentially, the solar radiation is the portion of electromagnetic radiation which is given off by the sun in particular forms such as infrared, visible and ultraviolet light. As we consider the Earth's surface, the sunlight which is reaching this Earth's surface could be coming as direct solar radiations, the way it is shown here in the blue line, whereas it could be interacting with the various gas molecules, the dust particles that are present at the upper layers, and accordingly as it gets filtered, it would be termed in the diffuse solar radiation manner. Also, as the solar radiations are reaching the Earth's surface and as they are absorbed, the portion of it will be emitted back in the upper atmosphere. So accordingly, it would be outgoing thermal radiations. These solar radiations will be changing according to the atmospheric effects, including the absorption as well as the scattering of the particulate as well as the gas molecules that are present in the upper reaches. Also, there will be local variations because of the presence of the water vapor, cloud, as well as even the presence of the pollutants. The solar radiations which will be reaching to the Earth's surface will be changing according to the location of a particular place, as well as it would also be changing according to the day, time, and even the season of the year. Let's try to understand the atmospheric interaction with incoming solar radiations. We just consider the effect of the presence of certain dust particles, gas molecules, or the water vapor in the upper reaches. These particular particulate are receiving the amount of this insolation. Partly it will be absorbing, partly it will be transmitting, as well as partly it will be even reflecting back the portion of the electromagnetic energy being received. So as we consider the effect of this scattering, it reduces the amount of incoming solar radiation reaching the Earth's surface, as the significant portion of these short-wave solar radiations reaching the Earth's surface are reflected back to the space. Also, these gases and particles absorb the incoming insolation, and this absorbed solar radiation is stored in the form of heat energy. As the energy is stored within the body, that body itself acts as the source of the energy, and it starts emitting its own radiations. If we consider the reflection which is occurring in the redirecting the energy being received exactly in the opposite direction, it would be net loss of the insolation being received. Also, as we consider the most of this particular reflection within the atmosphere, it is mainly because of the air molecules, the aerosols, and the various gases that are present with it. Also, as we consider the reflection, which is also termed as albedo due to the presence of the clouds, this can range from 40 to 90 degrees centigrade, 40 to 90%. As we consider the reception of these solar radiations, there is a continuous transfer of the energy as they travel within the atmosphere with the speed of the light. So as these solar radiations take about 8 minutes 20 seconds in order to reach the Earth's surface, they will be radiating the amount of the energy, and this can be considered in terms of radiation intensity expressed in relation with the wavelength of that electromagnetic wave. As you see here, this radiant intensity over the solar spectrum is changing according to the wavelength. About 44% of this particular energy transfer is occurring with the portion of visible light, whereas within the range of the ultraviolet light, the radiant intensity is about 7%. For the near infrared region, it is about 37%. So as we discussed previously about the insolation, the energy being received is in the terms of this insolation. If we consider the surface which is receiving the energy and placed perpendicular to the direction of this energy, The amount of the energy received can be considered in terms of the solar constant, which is 8.16 joules per square centimeter per minute. As shown in this particular sketch, if we treat this particular incoming solar radiation as 100%, 19% of this energy is absorbed by the atmosphere and the clouds, whereas the 51% of it is absorbed by the Earth's surface. Around 4% of this energy is reflected from the Earth's surface. About 20% of it is reflected by the clouds, and about 6% of these incoming solar radiations are reflected by the atmosphere. This insolation will be changing according to the angle of incidence, the location, the time, the season, as well as composition of the atmosphere. The first parameter can be considered in terms of angle of incidence of the solar radiation. So this angle of incoming solar radiations influences the seasonal temperatures of the locations at different latitudes. When the sun's rays strike the Earth's surface near the equator, the incoming solar radiation is perpendicular to the surface and has got lesser intensity as compared to the region placed at the higher latitudes. So as the energy is concentrated over the smaller surface area, there will be more warmer temperature as compared to the place which is receiving the slanted solar rays. As such, at higher latitudes, the angle of solar radiation is smaller, causing energy to be spread over the larger area of the surface, and hence, comparatively, it will have the cooler temperature. As the angle of the radiation varies depending on the latitude, surface temperatures on average are warmer at the lower latitudes and cooler at higher latitudes, even if the higher latitudes have more hours of the daylight during the summer period. This angle of the incidence has got pronounced effect because of the relative size of the Earth, which has got the diameter of 12,700 kilometer as compared to the huge diameter of the sun, and even the temperature difference and the distance in between the Earth and this sun is very high. We can compute the angle of solar radiation, which is demonstrated with this small example. Here we wish to compute the sun's angle over a city which is located 39 degrees north latitude, whereas the sun which is placed at 21 degrees south is causing that rays to reach that city at 90 degrees. So as we consider this particular triangle, and as we consider some of these particular included angles to be 90 degrees, some of that included angles to be 180 degrees, here this is 39 degrees. The sun's angle below this horizontal line is of 21 degrees. This will be 90 degrees. Hence, the sun's angle over a city can be computed as 30 degrees. Even as we considered the position of the earth in relation with the sun and the reception of the solar radiations, during the daytime it will be changing. As far as the countries which are placed in these particular middle latitudes, they will be receiving the more solar energy in the summer, as during that particular days are longer and sun is nearly overhead. Whereas during the winter months, the solar rays will be more slanted during that shorter days. The rotation of the earth is also responsible for hourly variations in the sunlight. In early morning and in the evening, the sun will be low in the sky and it will be causing lesser solar radiations reaching the earth's surface, as they are getting distributed over the larger area as compared to the noon when the sun is at highest point. We discussed about the geographical location and the angle of solar radiation reaching to that particular location. Some of the things can be summed up as the earth is spheroidal and the solar radiations strike the surface at different angles ranging from 0 degrees just above the horizon to 90 degrees, that is directly above the head. When the sun rays are reaching exactly vertical, the earth's surface receives the more energy, which is related with the regions placed in the middle latitudes. The rays, as they become more slanted, and obviously they have to travel through the atmosphere with the longer path, and hence it will cause the rays to be scattered as well as diffused. The polar regions will never get this high sun because of the tilted axis of the rotation, even the during part of the year. We know that the earth revolves around the sun in elliptical orbit and it is closer to the sun during the part of the year. When the sun is nearer to the earth, it will be receiving more solar energy. The 23.5 degree tilt in the earth's axis is more significant factor in determining the amount of sunlight striking the earth at particular location. The tilting results in the longer days in the northern hemisphere from the vernal equinox to the fall equinox and longer days in southern hemisphere during the other 6 months. Whereas, as we consider the equinoxes, the days and nights are both exactly 12 hours long, which occur around March 21st and around 22nd September. As we consider this 21st or 22nd March, here the sun crosses the celestial equator in the northern direction. On this day, the sun is in the plane of the equator. There will be larger days in the northern hemisphere and hence the shorter nights. Hence, it is termed as spring or vernal equinox in the northern hemisphere. The situation will be exactly opposite in the southern hemisphere. Hence, it is said to have autumnal equinox as far as southern hemisphere is concerned. As we consider this 21st or this 22nd June, the sun is placed farthest. It is in the plane of the Tropic of the Cancer. It would be the longest day of the year for the summer in the northern hemisphere, whereas there will be shortest day of the year in the winter in southern hemisphere. In the northern hemisphere, it is said to have the southern solstice, whereas in the southern hemisphere it is termed to have the winter solstice. As the poles are not receiving the sun overhead, on this day there will be 24-hour daylight in the northern hemisphere, whereas there will be 24-hour darkness in the southern hemisphere. On the opposite direction, as we consider this particular 21st or 22nd December, the sun will be in the plane of Tropic of Capricorn. There will be winter solstice as far as northern hemisphere is concerned, whereas there will be summer solstice in the southern hemisphere. There will be 24-hour daylight as far as South Pole is concerned, whereas there will be 24 hours darkness as far as the North Pole is concerned. The distribution of the solar radiations also change according to the atmospheric composition. Already we have studied that Earth's atmosphere comprises of 78% of the nitrogen, 21% of the oxygen, and presence of certain argon and other gases. The Earth's atmospheric energy balance is the balance between the incoming energy from the sun and outgoing energy from the Earth. As Earth receives the solar radiations, it further irradiates these long wave radiations within the range of 4 to 12 micrometer near infrared range. As we consider these re-radiated long wave radiations, the water vapor that is present in the upper reaches near the Earth's surface, as well as this carbon dioxide that is present near the Earth's surface, it absorbs these particular radiations and accordingly it blocks the outgoing longer wave radiations. As the long wave radiations are absorbed, the energy won't be dissipated in the upper atmosphere, but it will be stored in the vicinity of the Earth's surface. Hence, it will cause the warming of the atmosphere. On the other hand, as we consider the presence of the particulate water vapor as well as the dust particles, their presence will cause the scattering of the energy reaching to the Earth's surface. So, as the energy is not reaching to the Earth's surface and as it is reflected back or scattered in the atmosphere, this will cause the reduction in the temperature of the atmosphere. So both these effects are exactly opposite each other. Here in this case, the energy is stored in the atmosphere, whereas here the energy is not allowed to reach in the lower atmosphere and hence the reduction in temperature. However, it is not that easy to predict which effect will override each other. So thanks for your attention. I hope the discussion that we made for understanding the interaction of the solar radiation with the Earth and associated changes in the temperature is clear to you. So as we move ahead, we'll discuss about the atmospheric stability. So bye till then, I wish you very happy learning. Thank you.